Welcome, my dear students. I would like to introduce some practical applications on differentiation. This video contains important problems for math lovers.
A rope of length 25 meter passes over a pulley at height 12 meter from the ground, tied at one of its ends by a mass and the other end by a car. Moves with velocity 6 meter for every second. Find the rate of change of height of mass at the moment that the car at a distance 16 meter from the projection of the pulley on the ground. As you see in this figure now, this is a pulley, mass, car. Dear student, please draw this figure in your notebook to imagine what will I say in the next steps. Every step depends on the previous. So you should write what I drew or what I write, step by step. Let the height of the mass equal h, and the distance of the car from the projection of the pulley equal x. From the figure, review the figure, please. Therefore, BC equal 12 minus h. And EB equal 25 minus open bracket 12 minus h, close the bracket. Review the problem. The length of the rope is 25. Subtract 12 minus h, which we obtained in the previous step. This equal what? Equal 13 plus h. From the figure, apply Pythagoras theorem. Therefore, 13 plus h all square equal x square plus 12 square. And now, by differentiation, differentiate the two sides. Therefore, 2 times 13 plus h dh by dt equal 2x dx by dt. At x equal 16 from the equation 1, at x equals 16 from equation 1, this equation number 1, at x equals 16, what will we have? This from what? By substitution in this equation, put x equals 16 here, we obtain This 13 plus h all square equal 400. Therefore, h equal 7 meter. Dear student, write this part in your notebook because the next step depends on this part. To imagine and to understand the next step, you should write this in your notebook, please. By substitution, therefore, 2 times 13 plus 7 dh by dt equal 2 times 16 times 6. By substitution. Therefore, dh by dt equal what? For 0.8 meter for every second. In a closed electric circuit, V is a potential difference in volt, I is the current intensity in ampere, R is the resistance in ohm. If the potential difference increases at rate 2 volts for every second and the current intensity decreases at rate half ampere for every second, find the rate of the resistance at the moment which V equal 24 volt, I equal 4 ampere, given that V equal I times R. Dear student, write the problem in your notebook, please, to imagine what will we do in the next steps. Every step depends on the previous. Please write the problem in your notebook. Solution: since V equal I times R, differentiate both sides with respect to time. Therefore, dV by dt equal I dr by dt plus R di by dt. Dear student, write this part please in your notebook because we will need it in the next step. Every step depends on the previous. Please write this now in your notebook. Since dV by dt equal 2 volt for every second, di by dt equal negative half ampere for every second, V equal 24 volt, I equal 4 ampere. Therefore, what will we have? What will we have? Therefore, R equal V over I equal 24 over 4 equal 6 ohm. This is from what? From substitution in the equation in the previous part. Review the previous part. Therefore, 2 equal 4 dr by dt plus open bracket 6 times negative half close the bracket. Dear student, write also this part in your notebook because the next part depends on it. To understand the next part, you should write this part in your notebook. Write this part in your notebook, please. Therefore, 2 equal 4 dr by dt plus negative 3. Therefore, 3 plus 2 equal 4 dr by dt. Therefore, 5 equal 4 dr by dt. Therefore, dr by dt equal 5 over 4 ohm for every second. And this is the rate of the resistance.
Best wishes from me for all of you and thank you very much. Goodbye.